Welcome to Ask and Learn.
Let's find the absolute minimum and absolute maximum values of the function f of x equal x times exponential of x half on the interval -3, 1. First, we know that this function is continuous over this closed interval, and for that reason it attained its extreme values over that interval. And we know moreover that the the extreme values of the function are attained at either the endpoints of the interval or critical numbers of the function. So we start by finding the critical numbers of f. For that, we need the first derivative of f, which is the derivative of this product here, x times exponential of x half. And that is the derivative of x, which is 1 times e to the x half plus x times the derivative of e to the x half is the same exponential function times the derivative of the exponent, which is 1/2. And that is e to the x half common factor of 1 plus x over 2, and that's the same as 2e to the x half times 2 plus x. And that's the expression of the first derivative of f. And we see that this derivative exists for every value of x in the interval from -3, 1. And for that reason, we can say that the only critical numbers of f in the interval from -3 to 1 are those values of the argument x in the interval from -3 to 1, for which the first derivative is equal to 0. So we got to solve that equation, first derivative equals 0, and that's equivalent to the equation 2e to the x half times 2 plus x equals 0, because the first derivative of f is given by this expression here. And we know that 2 and the exponential of x to the x half is always positive, so it's equivalent to saying that 2 plus x is 0, and this is the same as x equal -2. So the only critical number of the function in the interval from -3 to 1, closed interval, is x equal -2. So now we get to evaluate the function at this critical number and at the endpoints of the interval, that is -3 and 1. And from those values, we have the extreme values of the function. So first, the image of -3 is -3 times e to the -3 halves. And that value is about, if you use a calculator, to -0.6693904804. Now we evaluate at the ready point, which is 1, and we get 1 times e to the 1/2, that is square root of e, which is about 1.648721 2707. And finally, f at the critical number -2 is -2 times e to the -2/3. Sorry, I made a mistake here. It's not like that. It's -2 times -2 half, I meant. And that is negative 2 e to the negative 1, that is negative 2 over e, and that's about negative 0.7357, properly 7357, 5, 3 times 8, 2, 3. And that's the three images we need. And now we see from here that the largest value is 1.6487, etc., because this is greater than the other two values, and it occurs at the writing point 1. The exact value is right square root of e, and the smallest of these values is negative 7357, etc., which is negative 2 over e, and that occurs at negative 2, which is the critical number. So now we can say the answer to the problem is that the absolute minimum value of the function on the interval negative 3, 1 is, so here negative 0.7, which is negative 2 over e, is negative 2 over e, which is about negative 0.73575 through triple A 23, and that absolute minimum value occurs at the critical number x equal negative 2. That's about the absolute minimum. And now the absolute maximum value of the function on the closed interval from negative 3 to 1 is square root of e, which we know is about 1.6487212707, and that absolute maximum value occurs, okay, so here, occurs at, in this case, at the writing point of the interval, at the right endpoint, x equal 1. And so this is the answer to the problem. And now we gotta recall what we did here. The first thing is to notice that the function being continuous and defined on a closed interval, we know that it attains its extreme values on that interval, and the points where, or the values where the function attains those extreme values may be either the endpoints of the interval or critical numbers of the function in that interval. So to find the critical numbers, we find the first derivative. We notice that that derivative exists for every value of x in the interval, and so the only critical numbers of f in that interval are those values for which the derivative is 0. We state that equation, first derivative of f equals 0, and for that we get that the only critical number of the function in the interval from -3 to 1 is -2. Then we evaluate the function at the right endpoint, left endpoint, and the critical number, and we found that the largest of these values is square root of e, which is about 1.6487212707, and it is attained at the right endpoint of the interval, that is number 1. And the smallest of these values, which is then the absolute minimum value of the function over the given interval, is -2/e, which is about -0.7357538823, and it occurs at the critical number x equal -2. And so this is the final answer.